Math Day, Great Day, Math Lead learners! Welcome to Mathematics Lead channel, where we turn your math worry into mastery. I am Anne Valerie Aliasas, and together, let us have fun while learning. For today's topic, we will discuss factoring different types of polynomials. The first one is polynomials with common monomial factor, difference of two squares, sum and difference of two cubes, perfect square trinomials, and general trinomials. Let's have first the learning objectives, wherein at the end of the lesson, the student should be able to formulate real-world problems involving factors of polynomials, determine patterns in factoring polynomials, factor polynomials completely and accurately using monomial factor, factor the difference of two squares, and factor the sum and difference of two cubes. Before we discuss our lesson, let's have some engaging activities to have some background about polynomials. So, I will present some different polynomials and you will determine if it's a monomial, binomial, or trinomial. You can pause this video to answer it on your own and play it if you want to check if your answers are correct. So, the first one is monomial, the second is trinomial, then binomial, monomial, and lastly is trinomial. For our next engaging activity, we need to find the greatest common factor of each item. So the first one is 6, then the second one is x squared, then lastly is 7. And now, let's get started. First, let us define what is polynomials. Polynomial came from the word poly, means many, and nominal means terms. Polynomials are algebraic expressions that consist of variables, coefficients, constants, and exponents. These are combined using mathematical operation like addition, subtraction, multiplication, and division. And now, for our first topic, which is the common monomial factor. Common monomial factoring is the process of writing a polynomial as a product of two polynomials, one of which is a monomial that factors each term of the polynomial. To clearly understand that, here are some examples. The first one is xy plus the xj, and this is the solution to get the common monomial factor of this equation. As we can see, each term has a variable x, so we will factor out the variable x as our common monomial, and the answer will be x times the quantity of y plus z. And if we equate this equation, we will get the original equation, which is xy plus xz. Our next example is 5x squared plus 15x. The same as the process in our first example, but here the common factor of these two terms are 5x, since the factor of 15 are 1, 3, 5, and 15, while the factor of 5 is 1 and 5, and their greatest common factor is 5. While the common monomial factor of x squared and x is x, therefore, our answer will be 5x times the quantity of x plus 3. And if we equate this equation, we will get this original equation. Our next topic is difference of two squares. This is a squared number that are subtracted from another squared number. Every difference of squares can be factored according to this identity. A squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b. These are some examples. The first one is x squared y squared minus 36. And we need to find the square root of these two terms, wherein the square root of x squared y squared is equal to xy, and the square root of 36 is equal to 6. And we will have the equation of the quantity of x minus 6 times the quantity of x plus 6 because we use this identity. And our second example is a squared minus 9a raised to 4. The same as the process in our first example, we find the square of both terms, which is the a squared and the 9a raised to 4, and the answer is a and 3a squared. And we will have the equation of the quantity of a minus 9a squared times the quantity of a plus 9a squared. We also use this identity. So our third topic is sum and difference of two cubes. To factor a sum of cubes, we have the form the quantity of a plus b times the quantity of a squared minus b plus b squared. And to factor a difference of cubes, we have the form of a minus b times the quantity of a squared plus ab plus b squared. For example, x cubed plus 27. First, we need to make sure that each term is a perfect cube. So we will find the cube root of x cubed and 27. And the answer is x and 3. And now using this form for addition, which is the a cubed plus b cubed, we substitute the a into x and b into 3. Therefore, our equation will be the quantity of x plus 3 times the quantity of x squared minus the quantity of 3 times x plus 3 squared, which is equal to the quantity of x plus 3 times the quantity of x squared minus 3x plus 3. And this will be our answer or our equation. And for our second example, which is x cubed y cubed minus 8, we will use the factor of difference, which is this form. A cubed minus b cubed is equal to a minus b times the quantity of a squared plus ab plus b squared. So our a here is xy and our b is 2. We transform this into xy minus 2 times the quantity of xy raised to 2 plus 2 times xy plus 2 raised to 2. And our answer will be xy minus 2 times the quantity of x squared y squared plus 2x plus 4. And here is our equation. For our next topic, which is perfect square trinomials. A perfect square trinomial is a trinomial that can be written as the square of binomial. For a perfect square of equation with the operator of addition, we will use this one, which is the quantity of a plus b squared, while with the operator of subtraction, we will use the quantity of a minus b raised to 2. We need to make sure that the first and last coefficient is a perfect square, and twice the sum of the product of these two coefficient is equal to the second coefficient. For example is x squared plus 10x plus 25. So we need to make sure that our first term and our last term is a perfect square. So we will square root both terms, wherein the square root of x squared is x and the square root of 25 is equal to 5. And we need to twice these two to make sure that it is a perfect square trinomials. And if the product of this equation will be equal in our second coefficient, then we can say that it is a perfect square trinomials. So therefore, our x squared plus 10x plus 25x is also equal to the quantity of x plus 5 raised to 2. For our second example, which is x squared plus 4x, the same as the first example, we will square root x squared and 4, which is the first and last term of our equation, and we will multiply it into 2. And if we get the second coefficient, then we can say that it is a perfect square trinomials. So we can say that x squared plus 4x plus 4 is also equal to x plus 2 raised to 2. Lastly is general trinomial. A trinomial of the form ax squared plus bx plus c, where a, b, and c are real numbers. They are called general quadratic trinomials because they are quadratic expressions that are in a general or standard form. For example is p squared plus 5p plus 6. First, we need to list all the possible factor of our last term or our constant, which is 6. And the factor of 6 are 2 and 3. 6 and 1, negative 2 and negative 3, and lastly, negative 6 and negative 1. So next is, find which factor of 6 whose sum is 5, or our second term. So the first one is 2 plus 3 is equal to 5, then 6 plus 1 is equal to 7, then negative 2 plus negative 3 is equal to 5, and negative 6 plus negative 1 is equal to negative 7. So as we can see that the general trinomials of p squared plus 5p plus 6 is the quantity of p plus 2 times the quantity of p plus 3. And for the last part of our discussion, I will give some question and you need to try to answer it on your own to know if you understand our discussion and also to develop your understanding about our topic, which are the polynomials with common monomial factor, difference of two squares, sum and difference of two cubes, perfect square trinomials, and general trinomials. So here are the following questions. And here are the answers to check if your answers are correct. So great job everyone. I hope you understand our topic today about polynomials and thank you for watching and listening.